going to be using logarithms to find a point of intersection. So we've got two equations here. We've got y is equal to e to the x take 3 and y is equal to 1 take 3 e to the negative x. Now we know that this graph is just a normal exponential, natural exponential function that's been moved down 3 or translated down 3. This one has a lot more happening to it. It's been, so according to CBAD, been reflected in the y-axis. It's been reflected in the x-axis. It's been vertically stretched by a factor of 3 and it's moved up 1 or translated up 1. So find exactly the points of intersection and then check your solution using technology. We're going to do this the other way around. So let's have a look at the technology. Now, obviously you'd have a class pad, but I'm just using the Desmos graphing calculator. I put both my functions in and I've found my intersections there. So we found, or both their answers, the intersections are 0, -2, and we've also got 1.0990. Now, this basically has answered our question. How many intersections does it have? The next point is we want to confirm this answer using an algebraic approach. Now you may know that there's two answers that makes me think it might be a quadratic. So let's see what happens with that. So let's get rid of this now and get into the algebra to confirm our answer. So how are we going to work this one out? Well, we know y is equal to y. And I hope you're happy with that statement there. The reason we're doing that is we can replace those y's with whatever we see up there. So on the left-hand side and on the right-hand side, next step is it's good to get everything by itself because this is a quadratic. It may not look like one yet, but we can use a dummy variable to show that more clearly. So let's bring everything together. I'm going to keep, I know it may seem weird, but I'm going to put the constant in the middle as a middle term. And then I'm going to plus 3e to the negative x is all equal to 0. Okay, now our next step is to get rid of that e to the negative x. To do that, we can do something quite clever, is times by e to the x. What we do to one term, we must do to all terms. There we go. And then underneath, we're going to write out what that answer will be. So e to the x times e to the x is e to the x plus x, or 2x. This becomes 4e to the x. There. And we can see that e to the negative x times by e to the x, they basically go to e to the 0 or 1. So it's going to be plus 3 is equal to 0. Now, I'm going to factorize this the way I do. I don't use a dummy variable. So I know this is a quadratic. So what we have is we need two numbers that times together to make 3 and add together to make -4. So we know those numbers are going to be -3 and -1, right? So we can put that straight in a bracket. E to the x, take 3, and e to the x, take 1. It's all equal to 0. Now, if you didn't follow along with that, we can do something nifty. We can say, now y's already been used up, so let's use z. Let z equal e to the x, okay? So e to the 2x is going to become e to the x squared, take 4e to the x plus 3 is equal to 0. So that's going to be z squared minus 4z plus 3 is equal to 0. And if you factorize that, we can see it's going to be the same thing. And then we can swap that dummy variable back in. So I do hope that's helped. Basically, you can see it's the same thing, but there's a bit more work when you use a dummy variable, but you can see the quadratic clearer. So it's up to you which way you want to go. So let's get back to it. We've got null factor theory here. saying we've got two brackets and we need to make each bracket 0 to find both answers. First answer. Second answer. So I've got my x values there. I know it's a bit of a shortcut, but the opposite of e to the x is equal to 3 is x is equal to ln 3. So we found our x values. Now I'm just going to go over here to my decimals calculator. So this is 0, must be matching up with this coordinate here. This ln 3 we hope is 1.099. So let's check it out. ln 3. Yeah, there it is, 1.099. So we know that that's worked. So we've confirmed the x values of the our equation. Now we probably need to sub in just to double check that -2 will pop out for the 0 and 0 pop out for this ln 3. So I'm going to use the simpler formula. So I'm going to sub into this one here. And I'm going to change color to, let's go green. So let's sub in y is equal to e ln 3 minus 3. And we can see here that e to the ln 3 is just 3. So this becomes y is equal to 3 minus 3, which is equal to 0. Therefore, we have a first intersection point in exact form. And I'll just scroll down here. ln 3, 0. So we found it. Let's do the other one here. We're hoping that a -2 pops out for this one. In green again, y is equal to e to the 0 take 3. Well, we know e to the 0 is 1, not 0, as a lot of people think. -2 pops out, so our intersection is 0, -2. And we've done it, we've got both our answers there. So there we go, we've the other way around, but we've checked our answer using technology and then confirmed it using algebra. And yeah, it's pretty satisfying to get that matching up. And yeah, so I'd say the most tricky part of this one really is that times by e to the x, get rid of the negative x. But yeah, you've just got to be wary that if you see it in this form or e to the 2x, there's probably going to be a quadratic nature and there'll probably be two solutions. If it doesn't have that, there might only be one. All right, thank you very much. Hopefully this video is helpful.